Hello everybody and welcome back to Do Me a Solid. Today we are going to be going over the fill pattern tool in SolidWorks. So a couple of different ways that you can use the fill pattern tool are sheet metal, where you have venting. In this case it could be something like a computer case, or it could be an Xbox system case. It's basically a venting area where fans can blow air through the entire system. So that's one example. You can also use it in applications such as a knife handle where you need grips. So this was done by a fill pattern and a simple extrusion brought to a 45-degree angle. And this can be done on both sides and mirrored. As you can see, I purposely left out an area because that's where the mounting boss would be that would eventually connect a screw to both sides of these pieces. And then another application is material alleviation. In this case, it could also be just weight reduction in a piece of plastic. For this example, it could be anything from a speaker grill all the way up through a covering for a drone housing to keep a child from sticking their fingers inside of it. So these are a couple examples of the fill pattern. Let's get right into the demo here. So I have prepared a piece for everybody to take a look at here, and I'm going to roll it back so you can see exactly how I did these. But I wanted to stress that you can adjust the fill pattern to fit to some sketches, and as you can see here I have some predefined sketches that you can see how I filled them in, and I will scroll back so we can take a look. So let's see here. So first off, what I did is I took a regular sheet in SolidWorks and I extruded a boss, and I think I did this one something like 100 thousandths just for the sake of example. But what I also did next is I started drawing individual sketches for containing my fill pattern. So there's two ways of getting the fill pattern tool. One way is going up here to linear pattern and then dropping down to fill pattern. And then the second way of doing this is going to insert, pattern mirror, and then fill pattern. So those are the two ways you can select it. Now, I'm going to show you how I did the first set here. So the first set was basically a slot cutout that I put in the middle of whatever boundary I was going to use here. So when I took that and then I created the pattern, it set up the fill pattern to go within the boundary that I chose. Now, I'm going to highlight this so we can take a look at some of the parameters and you can see how this works. So the first thing you want to do is you want to select the fill boundary. If it is a sketch, sometimes they are going to require you to have a direction, which is in this case the line right here. Now, in the case of having a filleted area, I had a polygon that went all the way to the edge here, and then it just simply picked the corner for me. You can go ahead and pick any of these edges that you'd like to have the fill pattern move in the way that you need it to. You can control the distance between all of these pieces and the spacing. Now you might want to avoid getting too close so you don't have any overlap. In some cases, you can avoid the overlap by having super close instances, but you can also change the angle, and the angle can compensate for that. That doesn't happen in every case, but it is possible for that to happen. I'm just increasing the angle here to show you that you could do it, and in this case it doesn't work. So we're going to go ahead and spread them back out, and then we're going to reset this back to 0, or it could be 90. Now the next thing that I want to show you here is that here is where you select the feature that you would actually like to pattern. So in this case I selected my cut extrude here. I had to pick the boundary on the inside to make sure that I selected it. And then after that you can also pick instances to skip, like in the case of my knife handle. If I needed to put a boss here, for example, or if in the sheet metal we needed to insert a PEM, we need to keep this area relatively clean for that application, then this is where you would go ahead and select the instances to skip wherever you require those PEMs. I would suggest making a sketch ahead of time so that way you know exactly where you need to put them and then where they would be not interfering with your actual piece. So that's how I did the fill pattern for the slot there. Next we're going to go over the circle. So same thing goes for the circle. I did exactly the same thing as I did in the previous. However, In this one, what I did was I didn't add an edge, an offset boundary edge. So in this case, you can adjust the offset boundary here, and it'll cut down the number of instances coming from the outside of it by that number. So in this case, I have a 100 thousandths border on the outside of this, and then the further you make this border in, the less instances you'll have within it. Now, with the linearity of this particular pattern layout, what you can do is you can control that pattern angle like I suggested before, and you can control it so it looks more along the lines of being completely filled. You can also play with the spacing if you have to. You can make sure that if you do the spacing correctly, you can change the angle to show that these are not as close together, but they'll still fit within that parameter. So as you can see, I just changed the spacing to be closer, then I adjusted the degrees on the angle and staggered them a little differently, and then I have the offset, and now we have a fill pattern that takes away all of that material. And then if we control undo, control Z, we'll go back and you can see how the pattern was spread out previously. And then the last one, as far as the cutouts are concerned here, is I did a hexagon here. Same concept. I did exactly the same thing. I didn't add any border restriction here, no offset restriction, no degree change, and I simply kept the pattern where it actually suggested that I put it. Now, these are all well and good, but the most interesting one that I wanted to show everybody was the boss and body pattern, because it's the most fun out of all of them for me. So what I did here is I was going to make a ring, for example, to measure the amount of spaghetti noodles or maybe PLA that you'd be using in a 3D printer, and to see how much I could fit into a circular area. So the first thing I did was I cut out a circle, and in this circle is where I want to find out how many of a certain extruded body I can fit within it. So the next thing I did was I extruded a body. In this case it would be PLA, spaghetti, whatever you want. And then following that, because I know that the fill boundary is going to require not only the circular fill boundary that I'm going to use, but it also needs a direction. So I took this sketch and I converted the circle, and then I added a direction from the center all the way out to the edge. So this is going to be helpful for SolidWorks just to understand which direction you want to fill the boundary in. Okay, so after that, what I did is I did the actual pattern. And how I did this is that I selected the body here, and then after I selected the body, I selected sketch 26, which was the circle, and then I selected the line, which is the dotted center line, and then what I did is I started playing around with the parameters I mentioned previously. So I made them as close as I possibly could for the sake of this video, and then for the sake of being able to squeeze as much as I can. But as you can see, when you change the degree, you're spreading them out more evenly. And then eventually it'll get to the point where you'll be able to fit more spacing between them. But it's nice because you can change the spacing between as well. And then change the angle. And then spread it out so that it's visually even. And in the case that I had previously, what I had done is I had taken the fill pattern and made them as close as possible without adjusting the spacing too much. So as you can see, I used the angle to control how close these bodies were. And then once I did that, I started messing with the spacing over here. So 55 was too close, 59 was just barely, 60 was a good spacing, and then if you change the angle, you can also go ahead and squeeze them even more. So this is a really interesting use because you can test how many bodies ended up within that area. So you go over here to validate the count, and then it'll count literally how many of those bodies can be contained within that circular area. So then, like I said, if you start playing with the degrees here and you're still not touching, you're barely touching, but you are, your validation count will change. So it was 181 with the previous angle, and then when you adjusted the angle and hit validate count, you got to see how many bodies there were in there. Okay, that's all for today's video. If you liked it and learned something, please like and subscribe. And please make sure in the comments to put what you'd like to see in future videos. Thanks. Take care.